All right, so today we are going to talk about what's new in wireless. Some of you already know all about wireless. There is a lot of things which have happened in the last few years. And so what's happening is what it is about. IP traffic. So this is the actual number. Not that it gives you any more result than what I told you, and not that I want you to remember that it will be 168 whatever exabytes per month. But the idea is that it is going, and it is somewhat faster than the linear, but in my view, this is under prediction. Personal view. In my personal view, all the predictions are under prediction because nobody has seen the change. Okay? Everybody says the life will remain the same as it is today, and they predict. But the life is changing. And it doesn't go like this. I mean, very few things go like this, but most of the things are going like that. Okay? And so, right now, this is the number as far as Cisco can see. And this is where the 3x in 5 years comes from. You look at 59.9 to 168, that is 3x. Number of devices. So basically, one of the things that is common to all these graphs that you will see, the bar charts like this, the highest frequency thing is in the bottom. So the blue thing is the bottom, and let's try to see which is on the top. Top is other, so this is M to M. So machine to machine will be most of it. Number of devices, in terms of number of devices. So what is machine to machine? Basically, right now, generally there is a human being at the one end of most of the connections, internet connections. But in the future, human being will not be there. Your watch is talking to your phone is talking to your fridge is talking to your power supplier, grocery store, who knows. So this is basically machine to machine traffic. Right? And that's how it is 3x the population size, because population is not talking, it's the machines which are talking. Right? Then we go to the non-smartphone. The next thing is smartphones will be doing. Now this is a number only, right? So this is not the traffic. Just the number of M2M connections, number of smartphone connections, number of non-smartphone connections, number of TV connections, number of PC connections, tablet and others. So actually this is interesting that the tablets are only 3%. Now these two numbers, by the way, are 2014 and 2019. So they were 3% in 2014 and only 4% in 2019. I think it's very, very low, under prediction. But I don't have any better data. So, and I can argue, I can disagree, but can't present you a better number. So according to them, this is the future. Total traffic. Now the thing is, we worry about it. So there are sometimes we switch to numbers, sometimes we switch to connections. Now we are talking about the bytes. Again, most of the bytes will be coming from PCs though. Let's see. Yeah, PCs are at the bottom and the other is at the top. You see, while PCs are going down in the numbers, but they produce a lot more than the smartphones even. Okay? And so you see, in 2014, the smartphones did so little, but it is growing very fast. So the growth rate is faster. The PCs are not growing very fast. They're almost constant, but they're big. Yeah.
Why that is fastest growth rate in Middle East and Africa?
Oh, because actually this will come up more later on. As I said already, is that I think somebody must have heard it. Why is it fastest growth in Middle East and Africa? Tell me. Did you hear something I said? Because their numbers are small. See, the thing is, if you are here and the world is here, you have to grow fast. Right? If you are here and the world is here, you cannot go very fast. Did you get that? Yeah. Okay. So the rates in the countries where Africa, for example, I wouldn't go to Middle East. Africa, for example, you can see the things are over here. Right? And they have to grow fast to really catch up. Do you agree? Okay, that's the reason. All right. I mean, actually here itself, let's not go to countries. the PCs are very high and the laptops, smartphones are very slow. So they will really grow fast, although they will still be less than the PC. The small things can grow faster. So the thing is, marketing people will make a deal about things whichever they can make a big number, right? So if the traffic is less, they will say the rate is high. Okay? If the traffic is more, then obviously they will say, if you are a PC seller, what will you say from this graph? Oh, PC will keep the last traffic. And here it is, they will do so many exabytes and the mobile will do only so many exabytes. And they will win, right? And if you are selling smartphones, then you don't talk about the absolute numbers, you talk about the rates. So rates can be lying, right? And they would not even say 3x, they will say 300%, because that 300 sounds very good. I'm saying 3x. And so some of these are marketing slides. All right, I think this is clear now, right? Yeah.
I'd like to ask, what do you mean the machine-to-machine thing?
Yeah.
Does it include the sensor thing to machine?
Yeah, that includes sensor to machine. Actually, most of it is actually in the industry. Machine to machine, most of the industries today already are interneted. They are already connected. You don't have people standing at every machine doing everything. Basically, machines do themselves and they tell every machine what to do. So that is called industrial internet, and that is machine to machine. It's not really at the home right now. Video on demand. Now we come to the video. And what is happening in the video is that you see I have shown three things here: standard def, high def, and ultra high def. So 4K is coming in. Ultra high def is 4K. If you go to buy a TV today in Walmart or any other place, 4K is what they're selling, or 4K is what people are buying. And HD TV was last year. That is old story now. Ultra high HD is now the thing. So they're showing that standard is going down, standard TV. HD is going up, and 4K is coming up. Obviously, the 4K would be very high, but the quantity would be less. IPv6. So, of course, people keep asking, in the United States in particular, when is IPv6 coming? So, this one is basically showing that, according to Cisco, it will go 3 times in 5 years. 2 billion to 6 billion, 3 times. 1 billion, 3.7 billion. These are the fixed devices and mobile devices. Both ways, 3 times more, yeah.
Are there any countries where IPv6 is standard right now?
Okay, so IPv6 is standard worldwide. First of all, the question of a standard was done in 1991. Okay, so it is standard worldwide. However, one of the things in networking is that whatever exists, people just don't throw it away. So nobody is throwing away IPv4. All right, and because of that, the other thing is not coming in. And my laptops, both of these have both IPv4 and IPv6. Okay, the laptop that you're using, I can bet that they have IPv6. So it's all there, but you're not using it because the other people are not using it. You don't find a website which says, sorry, I don't take IPv4 traffic. All right, and so there is no IPv6 only website. There is no need for me to switch to IPv6. Right? So I continue to use IPv4 and I don't even enable IPv6. I think it is probably enabled here, but there is no reason for me to really use it much, right? So that's the problem. But in some countries, and again I can go back to Asian countries, there is not enough IP addresses, IPv4 addresses. In the USA, we are lucky because we were here first, so we kept all the IP addresses for ourselves. So every student has an IP address. I mean, my computer, they have public IP addresses, both of these right now, right this minute. You cannot have this luxury in anywhere else in the world. Okay, one university will have one IP address, IPv4 address. So they got to use IPv6. So it will come there much faster. So this is global. Because if it was US, the number would be low. Now the countries, more story about the country. So you see the bottom is blue, which is Asia Pacific. Okay, so Asia Pacific is very low, but it's going to grow up very fast to become 33.7%. And America, right here, North America, which is US and Canada and Mexico, they will become 27% and so on and so forth. So the Asia Pacific has the highest growth rate. Middle East is 106%. So Middle East is, okay, so here's the thing now. Now you see, Middle East is growing highest. You cannot even see from this graph though, because the numbers are so small. 6.5% out of, something like 1/10 of that. So that's why I'm showing both types of graphs here. So by looking at this graph, you know that you're not just going to go and start a business in Middle East. Because if you have, the thing is growing very fast, but the amount is small. So basically right now actually for companies, from companies' point of view, Asia Pacific is hot. Because the amount is large and the growth rate is not bad. 33%. IoT, Internet of Things. And you will hear about this a lot. So this is the number of M2M connections. Billions of M2M connections. 2 billion, 4 billion, 6 billion, 8 billion, 10 billion, 12 billion. M2M. We were talking about M2M. And most of it is going to be in home. Actually, according to this, right now it is home. And manufacturing is green. So I was saying that most of this M2M is in the industry. That is not true according to Cisco. And so I may correct that, but I kind of would disagree with these kinds of numbers. My home doesn't have it. So I don't know which home has it. Okay, these are the M2M connections. According to them, we should have about 2.5 billion connections right now in the United States. This is what? Connected home. Well, this is worldwide, so but I don't see anywhere else either. If they're not in the United States, where are they? Yeah.
Why do you think the growth is so much more in the home than in enterprise setting? Because the enterprise seems like it'd be able to adapt faster or at least have a higher.
Right. So here thing. Okay. You have to distinguish between the numbers and the total. And I give this lecture when I go to India. In India, everything is large in numbers. It is 3 times US population. Okay, all right. So 3 times, the population is 3 times. So everything is large in numbers in India. But when you combine the total, it's very small. So you say the income, you take the income, you take the TVs, you take anything, cars, large in numbers, but the total is small because that is the design. Right? So I was going to bring it to the industry versus homes. There are a lot many more homes than industries. In this city, how many homes are there and how many companies are there? Right? So when you count, and this is a count, the homes will win, but when we see the traffic, it may be a different story. However, we just noticed that is not a different story because they don't watch video. So, so that explains that part.
But it doesn't necessarily mean that the home will be more profitable.
Well, actually, that is what the industry is believing right now. So let me tell you what is happening in the industry. In the industry, everybody is betting on the home except for GE. GE is going after the industry. So GE calls it industrial, something, I forget the name. So GE is betting there and everybody else is betting here. And the reason they are betting here is because Google invested $2 billion to buy a company that was making a thermostat, Nest. Right? That just woke up everybody. $2 billion for a thermostat. I mean, there is the Honeywell, they make all kinds of thermostat, man. Nobody buys them for $2 billion. Right? So, these are all, okay, so I don't know. I don't know about the future part, but this is basically where the current thinking is. And right now things are very cheap. I just bought a $3. For $3, I bought a Wi-Fi switch. So basically, I can turn on the basement light by my iPhone. And the thing costs $3. I don't need it, but why not? And so things are coming down, everybody is competing, and then the prices will be really depressed soon. I mean, because I don't know how they make money in that $3. After all, it is an electrical switch, which costs $3 anyway. Huh?
Mass production.
Well, I think they're just trying to get people used to it. Or, sometimes there are lots of reasons as to why things are at that price, that they want me to come to this store, which I then never went. Things like that. Anyway, so applications. So now we talk about applications, where all the traffic is going. So again, you see the bottom line right here, blue is internet video. And how does it affect your research? Why do you need to know in the university? Because if you don't do research which really addresses that problem of the video, the real time, the streaming, you are working on the wrong problem. There are a lot of people who are writing paper how to fix Ethernet, contention control. Come on now, CSM and CD. Nobody is using it. They don't even know that it is gone out of the world. They're still working on some old problem because it is mathematical. So if you want to apply mathematics, apply to things that people are using or people will be using. And that's why we study this. That if video is going to be there, the timing is key. What kind of video is it going to be? Is it the video which is stored? If it is stored, then the caching is the solution. If it is not, if it is a real-time video, like doing FaceTime, that cannot be stored on the CDN. How do you do that? Right? So these are the things that we need to know as to where the world is going, so that we can decide where we want to go. Okay, let me see. 80% of traffic is video. There is another problem with the video. Video is highly asymmetric. Because when you are watching TV, you are not sending anything to Amazon, maybe a few bits. Most of it is coming this way. Right? And asymmetric is a problem, because now you need a 10 gigabit link on which one lane is empty. The reverse lane, nothing is going on. So what do you do? I mean, either you design networks that are asymmetric or you do something, right? So that's the issue. So people are thinking about P2P distribution, which could make it symmetric. So when I am watching TV, you are watching TV, your neighbor is watching TV, Amazon only sends you one stream to your neighbor and you get it from your neighbor. So now your neighbor is uploading. So the bit becomes symmetric. And believe it or not, many things are P2P. I was just downloading something, and I forget where it was, from Microsoft or Apple or something. And then it gave me an option of getting it basically by a P2P, which means somebody else's home will give it to me. And then it asked me whether I will participate in that one to give it to somebody else, and I said, forget it right now. So P2P is coming in for that reason, because the traffic is so asymmetric that it is not worth sending gigabit from the original source.